of the nucleus. So yesterday we said that shell model is useful in finding the spin. So we found the spin. So spin is what? Spin is a J quantum number. So we say, okay, this is the J. And then now what we need, spin also and parity also. We covered spin and parity yesterday. Now we want magnetic moment. Now magnetic moment is only important from two point of view. One is gate exam and one is net exam. No one else will ask this. And also net has also asked only one or two questions. So not a very important topic. You just need one or two formulas and that will be done. Okay? So let's see what we can do. So what is magnetic moment? Because before I give you the formula, you must have an idea ki what is magnetic moment. Okay? For example, whenever anyone is magnet. So if someone is magnet, for example, our nucleus is a magnet, right? Nucleus is a magnet, and then nucleus is a magnet, and then the next thing is ki this question which you have sent is covered in the class 3. Okay, so nucleus is a magnet. So then it will have some two poles because magnet will always have the two poles. One is a north pole and another is a south. And whenever someone has two poles, we call it as a dipole. And in order to find the strength of this dipole, we say, okay, we define a new parameter which is known as dipole moment, or we also call it as a magnetic moment. Basically, magnetic moment tells you that how strong the magnet you have. And nucleus is a magnet. Nucleus has a magnetic properties. If you put a nucleus in a magnetic field, it will interact with it. So nucleus is some sort of a magnet, and the strength of that magnet can be found using the parameter known as magnetic. Okay. So with that said, how can we find that magnetic? So one thing that we assume is that the magnetic moment, so magnetic moment of the nucleus is coming from the last unpaired electron. So whatever is your last unpaired electron in the last electron or nucleon, sorry, last nucleon, because of that nucleon, your magnetic moment will appear. So yesterday also we said the spin is because of the last unpaired nucleon. In the same way, the magnetic moment is also because of the last nucleon. Okay. Now there are two conditions which can be fulfilled, and in 90% of the cases, only first condition will be fulfilled. Okay, now what do? I give you some nucleus, so you take that nucleus, you make a shell model structure for it, and then you find the state, and then you are able to find the what I can say is a basic state. Okay, this is the spin, this is a parity, this is my last nucleon, and so on. So basically, first step is do the shell model. Once your shell model is done, then look at the last nucleon. Focus on the last nucleon. If your last nucleon has a J equals to L plus half, for example, let's say J is 5 by 2 and L is 2. It means J is actually equals to L plus, because if you do L plus half, you will get J. Okay? So if this kind of situation is being obeyed, then you use this formula for magnetic. What is the formula? Formula is GL into L plus GS half into nu n. Nu n is a basic unit of nuclear magnetic moment. Basically, you can say is a magnetic moment of a one nucleon. So in this term, for example, the Bohr magneton we use in atomic physics. In this, we don't use Bohr magneton. In this, we use nucleon magneton or nuclear magneton. Okay? So this is a basic unit in which we define our magnetic moment. Okay? So what is the formula we have to use? GL into L plus GS by 2. And the value of GL and GS are known. So for example, if you are finding it for a proton, then the value of GL is 1 and value of GS is 5.586. Most of the time, the CSIR net gives you these values, but in one question, they did not give that. So it is best to remember these values. Even in one interview, they asked me these values. Okay, they said, okay, let's guess what will be the value. So if you already know the values, it will be better. You will be able to make better guess. Okay. So first of all, what is the situation? We have to understand. We made a shell model. We focused on the last nucleon, and then we use this formula to find the magnetic. Formula is GL into L plus GS by half into nu n. Nu n is a basic unit. We don't have to put the value of un. Your answers will be in the term of un, nu n only. Okay. For proton, the value of GL is 1 and the value of GS is 5.586. For neutron, the value of GL is 0 and the value of GS is minus 3.826. Why we have GL and GS, and what are GL and GS? GL and GS are the gyromagnetic ratios. GL is because of the orbital angular momentum and GS is because of the spin angular momentum. Okay? So these are the two things you should know. Okay, perfectly fine. Now, sometimes what can happen is कि your J is equals to actually L minus. Okay? That could also be possible. In that case, the formula will become this. So you just need to keep the formulas in mind. And this formula is very rarely used. More used formula is the first one. Okay? Because in most of the cases you will see what nu n is a basic unit of nuclear magnetic moment. Okay? So basically you can define your magnetic moment in these terms, just like a Bohr magneton do in atomic physics. Here we use nu n. So we have fixed one value of nu n, and then you don't have to remember that value. Even that value is sometimes experimental. Okay? So you always give your answer in these terms. Okay. So very quickly we will do one question and then let's complete this topic. Not very simple thing. So they are saying that according to the shell model, so this is a question from CSIR net. So they are saying according to the shell model, what is the nuclear magnetic moment of aluminium? Okay. So you know aluminium. Aluminium has 13 protons and 14 neutrons as shown here. Now you know for this I don't have to worry because this will be even. So all of them will be paired up. So no spin, no nuclear magnetic moment, nothing. What I need to worry about is this one, Z13. So basically because of neutrons, nothing is happening, but because of the protons, spin and magnetic moments are coming. Okay? Yes, GL and GL and GS are the ratios. They do not have any dimensions. Okay. Okay. So let's talk about Z equals to 30. So let's start filling up. So according to the shell model, you know first is S half. How many nucleons you can put? 2. Then we have P3 by 2. How many nucleons you can put? 4. Then you have P half. How many nucleons you can put? 2. And then you have D5 by 2. How many nucleons you can put? 6. But you don't have 6. You only have 5 left. So that is why you put 5. So you can clearly see 2 plus 4, 6, 6 plus 2, 8, 8 plus 5, 30. It means your last nucleon has the Z value 5 by 2. The value of Z is 5 by 2. And the value of L is 2. Value of L is 2. It means you can clearly see that J is L plus half. So I use the formula of magnetic moment, which is GL into L plus GS by 2. For proton, they have given you the value, although you can also remember this value, but they have given you. For proton, GL is 1 and GS is this. Why did not I use the value of neutrons? Because I'm not finding for neutrons, I'm finding for protons. Neutrons are not giving you any magnetic moment or spin. Protons are giving you in this case. That is why I need to use the values of for a proton. So GL is 1. So I put the value of GL as 1. And L key value, how much I have found? L key value I have found is 2. Why L is 2? Because you know for d orbital, L is 2. That is why. So I put the value of L as 2. And then I put the value of GS, which is 5.586. And then I divide by 2. That is also done. And then nu n. That's all. And then if you solve this up, you will get 4.793 nu n, which is your answer number C. So that is all you have to do. Okay. So there are some questions in the assignment related to this. It will help you in better understanding. But these are the formula and this is the question. So that is all you need to know for this topic. And here is the end of your shell model. Now what I'm going to solve is one question from the quantum mechanics, which is related to nuclear as well. But that question is basically how to find the bound states. And I will be doing complete derivation. And this derivation is important for every exam other than JAM. Other than JAM, every exam will ask this question. Okay? And has or had previously asked this question. Okay? So first of all, any doubts in this one? And